Ladies and gentlemen, hey, welcome back to Learning C#, or in the previous video I did call it C# 101. Either way works. Basically what we're doing, we're just going through lessons and lesson 7 here, which is expressions. The previous lesson here we did unary operators, and in this particular lesson here we're going to focus on the binary operators. Now, binary operators are those operators that work with two operands. A common binary expression would be like a plus b. The addition operator plus surrounded by two operands. Basically, the binary operators are further subdivided into arithmetic, relational, logical, and assignment operators. So if we look at the arithmetic operators here, we are going to go over multiplication, division, remainder or modulus, the addition, subtraction, shift left, and shift right. Now the first couple here are pretty self-explanatory. Addition, subtraction, pretty self-explanatory. But the remainder and the shift left and right operators are a little different, so we'll go a little bit slower through those, but the first couple here we'll just kind of like fly through. So multiplication operator evaluates two expressions and returns their product. Basically, it takes one number, multiplies it by the other number, and gives you a result there. So if we want to take a look at this in the actual code, we'll go ahead and just expand the multiplication section here, uncomment it. Whoops. So basically we have two variables here, x and y. X is set to 1, y is set to 5. And then we have a product variable here, which is equal to x times y. And we'll just go ahead and output those results to the screen. And as you can see, our product would be 5, since 1 times 5 or 5 times 1 is going to give you a product of 5. Pretty easy. Everybody should be pretty familiar with basic multiplication and basic math and things like that. So our next one here is the division operator. Again, simple mathematics here. The division operator, as it indicates, performs division. It takes a dividend expression and divides it by a divisor expression, returns the quotient. Again, here we got 45 divided by 5 is going to give us 9. But also, one thing to note when you're using the division operator here is the use of integers here in this expression. Had the result actually been a fractional number, it would have been truncated to produce the integer result, since integers have to hold a whole number, either positive or negative. You can't put 3.2 into an integer variable type. So again, we can go ahead and take a look at this in the actual code here, and we'll actually demonstrate doing a fractional one too, so you can actually see how that works here. Okay, so 45 divided by 5. We all know that the quotient's going to actually be 9 there. So now if we take 45, say, divided by 6, you know, we're going to get a whole number instead of what we should actually get. What would it be? Let's just pull it up here. My head mathematics aren't that great. So 45 divided by 6 would actually be 7.5, and as you see, we only get 7. So beware of that if you're doing division. You know, make sure you use the proper variable types to make sure you get the proper results. So now we'll go ahead and we'll move on to the remainder operator here. Some of us may be familiar with modulus math, some of us may not be familiar with modulus math. I like to call it modulus, some people call it remainder. You know, whatever way you want to do, I think they can be used interchangeably, but if not, I apologize for the error there. So basically, the remainder operator here returns the remainder of a division operation between a dividend and a divisor. A common use of this operator is to create equations that produce a remainder that falls within a specific range. Now take note, if there isn't a remainder, you will always get the dividend for a return result. To make it a little easier to understand, you can think of it this way. Some people sometimes don't understand why, you know, 3 mod 1 is going to be 3 when clearly it might not be, or like 4 mod 3 is going to be 3. So if you look at it this way, like say you have 4 people and you have 3 apples, and you need to evenly distribute apples among these 4 people. But since you only have 3 apples to begin with, you can't distribute them evenly, so you just don't hand out any of the apples to anybody. Therefore, you still have 3 apples in your hand, which that would actually be the remainder. So we can go ahead and take a look at this in the actual code here, and we'll demonstrate that 3 mod 4, or 3 remainder 4, is going to be 3. There we go, we got 3. So now if you actually pull it up on a calculator, you know, and you do 3 divided by 4, which it's similar to that operation there, but it comes up to be 0.75. So your remainder is not 0.75, since you can't evenly distribute the number you're looking for. It's a little difficult sometimes to grasp the concept of modulus math. There are a few times that you'll come across where you need to actually do this. I wish I could come up with a really good example right now, because I've written some applications in the past that have used modulus math to keep track of what's actually left with a given result, and if there was, you know, something there, we would continue going on. But I would suggest playing around with that a little bit, and if you aren't quite sure about it, you know, feel free to go and leave a comment, or you know, and ask questions and whatnot there. To our next one, which is going to be, the next two are going to be addition and subtraction. Very simple. I mean, everybody knows how to add, everybody knows how to subtract here. Obviously this operator here is for adding. This is very similar to the unary operator plus, but just remember that the unary operator always goes in front of the variable with no spaces, where the binary operator has an operand on either side of this particular operator. Example would be a plus b. The subtraction operator here is obviously just like the addition, except you know, it's for subtraction here. Don't confuse this one with the unary minus operator. Be careful of that there. So again, you know, we'll just look at the actual code here for addition. I was just taking 2 variables, adding them together, outputting our results. Same thing with subtraction, taking 2 variables, subtracting one from the other, outputting the results. Math 101 there. So the next two we're going to look at here is the left shift and right shift. Left shift operator will actually shift the bits of a number to the left when you can use the left shift operator. The effect of this operator is that all the bits move to the left that specified number of times. High ordered bits are lost, low order bits are filled with zeros. You can use this operator on types of int, uint, long, and ulong. So let's take a look and see how this actually works here. This might help you visualize it a little bit better. And again, we're using that small code snippet that I wrote to show the output of the actual bits here. So what we got here is we got a couple different integer variables here, number 1, number 2. And then we're going to show the binary output for number 1. And then we're going to go ahead and we're going to shift the bits to the left 1 spot, and then we're going to go output and put that result into number 2. Then we're going to output the results for number 2 onto the screen, so you actually see how the bits actually shifted here. So as you can see, our first number was number 1. So in the binary representation, that would be the first bit that's turned on. And then we're going to show the output for 2 now that we have shifted the bits to the left. Shifted the bits 1 bit to the left here, and now you can see that the actual bit was shifted, and now that result actually becomes 2. So you can shift bits around this way to create different results or different numbers, or do different things. Like if you're using an integer bits to store, you know, statuses, or you know, some type of maybe you can use it to even store error messages. Like, okay, hey, if, you know, like in our one of our previous examples there, you know, if, you know, bit 6 is turned on, that means it's this state or this status or this error message maybe that we want to indicate. So you can shift them around like that instead of having to, you know, do you know, power math and things like that. So the right shift operator is pretty much the exact opposite. Is that it'll shift bits excuse me, it'll shift bits to the right. So just like the left, except this operator moves the bits to the right, just as the name implies there. So again, we can go ahead and demonstrate that as well, using that code snippet again that we've created. So this case here, we're going to again take our numbers, number 1 and number 2 variables, and we're going to shift them around. So basically what we're going to have happen here is since we're shifting them to the right and we're already at the end, pretty much the number 1 is going to become a 0. So as you can see here, the binary output for number 1 is going to be 0000001, and then we shift them to the right, and now that number actually becomes a 0. So now showing the binary output for 0, now that we have shifted all the bits to the right there, and now we have a complete 0-bit string there, since the number is now technically 0. So shifting the bits left and right, and is pretty easy to actually do. Now you can shift them more than one spot. Obviously, this number here after the actual shift left or right operator here indicates how many bits it's actually going to shift. So if we actually if we go and we put in here, let's say we put in 64, and we want to shift the bits 3 places to the right, that should be what, 32, 16, 8. So that our final number should come out to be 8. And as you can see, there it is. So 64 is out here, and we go 1, 2, 3 to the right, and now our new output number will be 8. So like I said, you can shift them any number of positions that you want to. If you go too far, everything's going to be dropped off to a 0, like the slide showed there. I personally haven't used shift a lot, shift left or right. I probably could have, but I just found other means to do what I needed to do. Not saying that you won't use it, or come a time in your programming career that it's going to be mandatory that you use the left shift or right shift operators there. So out of these arithmetic operators, the ones I would probably focus most on would probably be left and right shift and the remainder. The remainder is a difficult one to probably kind of grasp your head around the most, because you're looking for a remainder of something, and you might not always get the results as expected. So maybe do some research on that one on the internet. There's a lot of different topics and discussions going on about that, and how to properly explain it to you if you don't quite get the gist of it here. So yeah, focus on those 3 if you at all a little confused on them, and just work with them. Practice makes perfect. Perfect practice makes even better. So now we can go on to relational operators. Relational operators are used to make comparison between 2 expressions. The main difference between relational operators and arithmetic operators is that relational operators return a bool type rather than a number. Another difference is that arithmetic operators are applicable to certain C# types, whereas relational operators can be used on every possible C# type, whether built in or not. These are still binary operators. They still require 2 expressions, so don't think that they don't there. So let's go ahead and look at some of the relational operators here. Let's see here. All right. So let's see. We'll move on. We'll go. Okay, we got the equal operator. So what we're actually looking for here is we're actually going to be testing to see if some things, if a certain value is equal to another value, and the equal operator is signified by the double equal sign. So basically, to test if 2 expressions are the same, you use the equal operator, double equal sign, to simply compare the 2 expressions, and it returns a bool result, bool or boolean. As you can see here, we have a couple of variables here. We have bool, which is our B result. We have a couple decimals equal to one set to 1500 and the other one set to 1395. And we're setting our B result equal to if our debit is equal, or our debit is equal to our credit. And so we know that our debit is not equal to our credit, so we're going to actually return a false there, because they are not equal. Now remember, when comparing floating point types, like plus 0.0 and negative 0.0 are considered equal. If either floating point number is not a number, equal returns false. Just keep that in mind there. So we can go ahead and take a look at this in the actual code and see what we can come up with here. Alright, now that we've got our code open here to take a look at some of our relational operators here. The first one we're going to look at here is the equal operator. Equal operator, like I said, is the double equal sign. And this, what we have written out here is we have just a Boolean variable set it equal to false. We have a just debit and credit. So basically, you could visualize this as being like an ATM, simple ATM application. So we have $1,395 in our account, and we're trying to remove or withdraw $1,500, and we're saying, okay, is our debit equal to our credit? And that we're going to look at that. Is it equal to? And if it is, we're going to allow the transaction to happen. If not, we're going to actually stop that. So if we take a look at it, and it says debit is not equal to credit, so our B result is going to be set to false. So equal equals, double equal sign is comparing the two values. Are they equal to each other? Another way, so pretty easy to understand. There's like, is 1 equal to 2? Is 2 equal to 2? Is 3 equal to 4? Things like that. Just compares the two, and if they are the same, return true. Otherwise, we are going to return false. Pretty easy one there to understand. You'll use equals, the double equal operator, extensively, so don't need to worry about practicing it or anything like that. All right, the next one we're going to look at here is the not equal operator. The not equal operator, which is exclamation point equal sign, is the opposite of the equal operator for all types. There is, however, a slight variation for floating point types. You might be able to see a pattern here that floating point types always have the exception. Basically, if one of the floating points is not a number, not equal will return true. You could say there are two forms of not equal for expressions. The first is the normal not equal to, the exclamation point equal to sign. The second would be a negation to the equal to sign. That would be putting your double equals operators and things like that in parentheses, and then on the outside of that putting the exclamation point, and that pretty much kind of says the same thing, not equal to. These two forms will always evaluate the same, with the exception of, yet again, floating point types. Again, this only occurs when one or both of the floating numbers is not a number. And the relational operator, in the negation of the expression, if less than, greater than, less than or equal to, or greater than or equal to, the A is greater than equal to B for evals to false. Evaluates to false, but the exclamation point A less than or equal to B evaluates to true. So basically, just floating point always has some type of weird exception to it there. So just keep that in mind when you're using floating point numbers, and you should be all right. So again, here's an example. We're going to use the same debit credit type of application again. And let's go ahead and hop into the code and take a look at that. So not equal to, alright, so again we have our result, we have our credit, we have our debit, and then what we're saying here's both ways you can write that out here. So here you have the negation of the equal to, and then we just have the not equal to. So we'll go ahead and start with just the not equal to, and basically what we're saying here is if debit is not equal to credit, we can't do what we want to do here. So we have, did I comment that top one out? Let me just double check. I think I did. Yes, I did. Okay. All right. So debit is not equal to credit, so our B result is set to true. True is our current value less than our limit. What is that? I think I forgot to comment one out here. Yep, here it is. Sorry about that. I always forget to do that. So basically, is debit not equal to credit? All right, debit is not equal to our credit. So our B result is going to be true. Now this would wouldn't probably be the right thing to do for an ATM application, but I'm just kind of demonstrating the purposes here. So what we can do is we'll go ahead and show you the other result, and they will be exactly the same. And again, debit is not equal to our credit, so our B result is set to true. Either way you do it, they're going to evaluate the same, except for floating point numbers. Sometimes it's easier to read the exclamation point equal to sign right here, because basically you're saying if debit is not equal to credit, rather than saying if not debit is equal to credit. You know, so it really all depends on your style and what you really want, but they're both the exact same thing. I use both interchangeably. Basically, if I'm doing like an if statement, though, 9 times out of 10 use this, unless I want to look for the negation of something. So whatever you really want to choose, it's entirely up to you. It doesn't matter what style you choose. Okay, next one is the less than operator. Now, when you need to know if a value is smaller than another, it becomes necessary to use these less than or greater than operators. In this case, we will look at the less than operator. The expression on the left is being evaluated, and the expression on the right is the basis for comparison. When the expression on the left is lower than the expression on the right, the return result is true. If not, the return result will always be false. So basically, is 1 less than 2? Of course it is. Is 2 less than 1? Obviously not. This is basic math stuff again that we all should know. But we'll just go ahead and take a look here. Run it in this example. So what we have here is we have two variables, red beads and white beads. We have 2 red beads and 23 white beads, and basically what we're saying here is do we have less red beads than we do white beads? Absolutely we do. So our B result of do we have less red beads than white beads is true. Pretty straightforward. Less than operator. The greater than operator is the exact same way, except it works in reverse. We'll just go ahead and look at that right now. And this particular example here, we are, do we have more red beads than white beads? Do we have more red beads than white beads? We absolutely do not. So our value is going to be set to false. Again, pretty straightforward, less than, greater than operators there. No real need to go into any deep conversation, anything or with them. So everybody should understand those. All right, the next one here is less than or equal to. Pretty much similar to less than, except we're also checking to see if it's equal to. Sometimes you need to know if a number is lower than or equal to a particular number. This is what the less than or equal to operator is for. This operator is the exact opposite of greater than, which means that the negation of A is greater than B would produce the same result. Again, the exception would be for floating point types. So in this example here, we're using a float limit, a floating point type with the name limit here. We set it to 4.0, and then we have our current value set to 3.86724, and we have a result. We're going to compare the actual two. And basically, we're just, for this particular example, you can imagine if you know, these could be pressures, you know, of some sort, and we're wanting to see if we are underneath our limit or at our limit. So even if it's equal to our limit, you know, we're okay. But if we're over our limit, then we would be false here. So again, we got is our current value less than our limit? It certainly is. We're at 3.86. So if we changed our current value to 4.86, we're going to see is our current value less than our limit? And it absolutely is not. So pretty easy. You're just comparing this one. Say, hey, are you less than or equal to? So if we actually change this one to 4.0, and we also get true, even though we're not less than, but we're equal to. So if we just pulled the equal sign out real quick, now we get the false, because now we aren't less than. So again, pretty straightforward. Easy to grasp the concept of less than or equal to. Again, it's math 101. Then we have greater than or equal to. It's the exact opposite. Well, I shouldn't say the exact opposite, but the reverse. So basically here we're saying, is our current value greater than or equal to our limit? And it is not in this particular case here, because 3.86 is less than 4.0. So again, pretty simple. Again, we probably don't need to go into great detailed conversation about that. Alright, so now let's move on to logical operators. These operators perform Boolean logic on two expressions. There are three types of logical operators. So you have bitwise, Boolean, and conditional. The bitwise logical operators perform Boolean logic on corresponding bits of two integrals, two integral expressions. Valid integral types are signed and unsigned ints and long types. I personally like to use these to store options on different states of objects. I think we've talked about this in the past, and we'll just go ahead and show a couple examples here in a minute. Boolean logical operators perform Boolean logic upon two Boolean expressions. The left expression is evaluated, and the right expression is evaluated. Then finally the two are evaluated together in the context of the Boolean logical operator between them. So basically it looks at both of them, and depending on which Boolean operator you're using, it will evaluate one or the other, or both of them together. Conditional logical operators operate much the same way as Boolean logical operators, with one exception in behavior. Once the first expression is evaluated and found to satisfy the result, the entire expression therefore after is not evaluated. So, and we'll take a look at this here, and these types of conditional logical operators, or conditional operators, can get you into trouble sometimes if you're expecting some results come in and it's just not quite working out right. It could produce some bugs that we'll get into. We'll talk about later in the lesson here. They're called side effects of these. But one way you can actually, look at this here, and to put in a real-world example, you could say it would be like continuing to search for your television remote or your car keys after you found them. So that's kind of how the logic or the conditional operators are split up like that. Okay, I found them. I'm certainly not going to continue looking for them, so I'm just not going to evaluate the rest of the actual if statement or expression or whatever we might be doing there. So let's go ahead and start with the bitwise and operator. The bitwise and operator, or the ampersand or the and sign, whatever you want to call it, compares corresponding bits of two, I'm just going to say integers, integrals is proper, and returns the results with corresponding bits set to 1 when both integrals have 1 bits. When either or both have a 0 bit, the corresponding result bit is a 0. I'm sure it's confusing. It's tough to understand when you're working with things that are difficult to see visually. So let's go ahead and take a look in our code here. See if we can help demonstrate that a little bit better. Okay. So the bitwise and operator. Okay, so we have two integers here. Number 1 set to 1, number 2 is set to 64, and the Boolean variable is bit on. So basically what we're saying here is, hey, is the bit position 1 turned on in number 2? So is the bit 1 turned on in number 2? And if you're familiar with binary math, you know that that is the binary representation of 1. And this would be, see that, 4, 5, 6, 7, 8. That would be the binary representation of 64. So by visually seeing this, you should know right now that the result is going to be false. And it is, because we know that bit position 1 is not turned on in number 2. So if you wanted to do something like, let's see here. If we change this to 65, oops, 65, is that right? That's not right. 65, we need to look for 64. Alright, so that one there is, okay, is 64 turned on in number 2, which it is. I had 1 there still, and we were still looking for number 1, and obviously that's not the case because 1 isn't turned on over here. So, but we do know that if 65 would be on, it would look like this. So we know that that bit there that we're looking for, which is 64, is on in that number, so our value comes back to being true. This is something I would definitely recommend messing around with a lot. It can come in quite handy in a lot of different scenarios. And me just showing it to you here, saying, hey, this is how this works, this, that, and the other thing, and trying to do my best to explain it, saying, hey, you just, all we're doing is we're looking to see if this number's turned on in this number, this bit position. Play with it a lot, mess around with it. There's some really cool things you can do with it. Like I said, I like to use them to store like states of objects, or maybe you have this set up to a certain type of error message system. Maybe if you're writing some type of application, and it doesn't have to be limited to an 8-bit number. You can do all the way up. You can go 128, 256, 512, 1024, 2048, 4096. You can keep going. It doesn't matter. All those bits are going to be there. So all you got to do is just look for them. If they're on, you can take your appropriate actions, whatever you want to do there. It's difficult to grasp the concept right away, but once you do, you'll be able to fly through it, and it'll be like second nature to you. So let's move on to the bitwise inclusive operator. All right, bitwise inclusive or operator compares corresponding bits of two integrals and returns a result with corresponding bits set to 1 if either of them have the 1 bit in that position. When both integrals have a 0 in the corresponding position, the result is 0. What does that mean for you? Well, if this bit is on in the first number, or that number is on the second number, the result will include the bits combined. So if bit 1 is on in the first one and bit 2 is on in the second one, your result will look like this. So your number would actually be 3 if you wanted to print it out to the screen. Let's go ahead and take a look at that. Comment this out here. Alright, bitwise inclusiveor. Alright, so basically if either of the bits are on and either number, combine the results into our result. So what we're going to do is we're going to start here with, let's just start with something easy first. We'll start with 1. I'm just going to put the binary representation up on here just to make it easier for you to see. And then we'll start with 2, not 64. Put that back to a 0. Put that back to a 0. And we'll put this as 2. So basically it's going to look like we're almost like we're adding the numbers together, because we're going to output the result of number 3. So, and it comes out to be 3. So it's kind of confusing when you do just numbers like that. Even if I went to like, well, I shouldn't say that. If we did this, if we turned this one on, so this number would become 3, the result won't be 4. It'll still be 3. Okay, because it's looking for if either or are on. Okay, so yes, these are on, so I'm gonna add those into my final number, and yep, one of these is on, so I'm gonna add that in my final number. So it's still, only the first 2 bits are going to be included. So if we took this one here and we added 128 to it and made it 127. Our final number is 127 because that one's on, so that one's going to be included there. 2 is on. So basically our result would come out to be this one, and 120. Oops, I did that wrong. This should be 129. Sorry. I wonder why it looked funny. There we go. Didn't think the numbers were adding up quite right there. I'm like, what the? Okay, yeah. So our final result here is bit position 1 is on, bit position 2 is on for a total of 3, and then 128 out here would be turned on. So our final number would actually be 131. Again, that looks like it's kind of adding together, but it's really not. It's just turning the bits on and off. So that one's a little easier to kind of see and see how that actually works. It just kind of flips them around, and you know, if they're on, you're going to include them into our final result there. So comment that out, and then we'll go ahead and move on to our next one. The Bitwise Exclusiveor operator compares corresponding bits and two numbers there and returns a result with corresponding bits set to 1 if only one of the integrals has a 1 bit and the other integral has a 0 in that position. When both bits are in the 1 or 0, the result bit is 0. What? What are you talking about? Well, it's easier to look at than actual say in words here. So Bitwise Exclusiveor. All right, very easy to see how this one works. So we have two numbers. I just like to use 8-bit numbers because they're really easy to see and work with, because everybody's kind of familiar with networking, I'm sure. And networking, IP4 uses 8 bits in each particular octet. So our first one here is 254, and our second number here is 240. And actually, let's set this to 255. It'll be a lot easier for you to see how this works here. So 255 is obviously all ones. What am I doing here? 255 is obviously all ones. 240 is the first 4 bits turned on. So, like I said, it compares, and only if one or the other is turned on. Okay, so these are different. So that's what it's comparing for. These are the same, so it's going to drop those. So our final result's actually going to be the first 4 bits will be turned on, and the last 4 will be turned off, because these match, these don't, so we want the ones that don't match. And you pretty much say that by number 1, and that would be the little caret sign, if you want to call it, or shift 6 on your keyboard. Number 2, and just compares them, and then if we output the actual number here, it's actually going to come out to be 15. Because the first 4 numbers turned on in an 8-bit string is 15. So again, it's really easy to visualize and see how that works there. Talking about it in text and showing you on the screen via PowerPoint, not so much. So just remember that. It always looks for the ones that don't match. Basically, okay, you don't match, I'm not going to include you. Clear as mud, I'm sure it is. But we're going to continue on here. And the next one will be the Boolean and Operator. This particular operator evaluates 2 Boolean expressions and returns true when both are true. Otherwise, the result is going to be false. So that would be like, say, if this apple is a fruit and this apple is edible, the return value would 99% of the time be true, because, hey, who wants to eat a rotten apple? But if that statement read, if this apple is a fruit and this apple is made of steel, that would return false, because both expressions are not true. So it's kind of you know, says, hey, this and this have to be true for it to evaluate to true. So let's take a look at that. What does that mean? That means this. Alright, we have a Boolean type variable here called inStock. We have it set equal to false. We have a price here as a decimal type set to $18.95. And then we have a Boolean type variable called buy. And in our statement here, we're saying in stock, if this is in stock and the price is less than $18.95 or less than $20, do we buy this? Well, we know that it's not in stock. But our price is less than 20. So what is our result? Should we buy this? Absolutely not, because both of them have to be true for it to evaluate to true. So if we turn this to true, now should we buy? Absolutely, because it's in stock and it's less than our budget. So just remember that there, that both, separate this out right there, both of these have to eval to true in order for this to become true. So this and this have to be true. Hopefully that makes sense. Should. That was pretty easy to understand there. This and this. Alright, Inclusiveor. The Boolean Exclusiveor operator, or the pipe, some people want to call it the pipe, evaluates the results of two Boolean expressions and returns if either of the expressions returns true. When both are false, the return value is going to be false. So if we go back to the apple thing again, it says if this apple is a fruit or this apple is made of steel. Now the return would be true because at least one of those expressions returns true. So let's take a look at that. In this example here, we're going to be using mileage and changing the oil. So we got mileage. Our mileage is set to 2305. Our months is set to 4. Our Boolean type variable here is going to be change oil. So basically what we're saying here is if mileage is greater than 5,000 or months is greater than 3, do we change the oil? Let's find out. It says true. Why? Because, well, we know our mileage is not greater than 5,000. That's only 2305. But our months is set to 4. So that is evaluated to true. And with the OR statement being right here, if one of them evaluates to true, the return result is going to be true. Not difficult to understand, hopefully. Basically, you just have two questions you're asking, basically separated by the pipe or the OR. The OR statement there, the OR operator, the inclusive OR operator, and you have the other question that you're asking here. And regardless of if one of them is false, it doesn't really matter. If one of them returns true, you're going to get a true. But if both of them are false, you're going to get a false. Let's just show that real quick. All right, so now both of them actually are returning false, and our return value is false. Pretty easy one to understand, I think. Not too complicated there. Let's move on to our next one. This would be the Boolean Exclusiveor operator, not the inclusive, but exclusive. The Boolean Exclusiveor operator evaluates the results of two Boolean expressions and returns true if only one of the expressions returns true. When both are true or both are false, the returning value is always false. Basically, that means the expression must be different in order to get a return, in order to get a result of true. That seems odd. Why would you want to use something like that? So basically, here's what we could say here. Uncomment this. Alright, so we have three Boolean type variables here. One, is it raining? Could it rain? Should we bring an umbrella? So, is it raining out? Absolutely not. Could it rain? Well, the forecast says it might rain today. So, we ask ourselves here, is it raining or could it rain? And we input that result into our, should we bring an umbrella? So, as of it stands right now, yes, we should bring an umbrella. But, here's where you can run into trouble. Is it raining out? Absolutely. Oops. It's raining out. Could it rain? Yep. Should we bring an umbrella? False. Got to be careful when you use the exclusive OR operators, because even though we technically know we should bring an umbrella, our code is telling us that we should not bring an umbrella. So you got to kind of watch out for these. One of those always they have to be different. So if you run into some weird logical bugs in your code, sometimes things like this can cause that, and they can be difficult to track down. So just remember, exclusive OR has to be exclusive OR. One or the other has to be a different value than the other. All right. Move on to our next one here. The conditional AND operator, which is the double ampersand sign, is similar to the Boolean AND operator in that it evaluates two expressions and returns true when both expressions are true. It's different when the first expression evaluates to false. Since both expressions must be true, it automatically assumes that the first expression is false and the entire expression is false. Is false and does not evaluate the second part of the expression. The second part only gets evaluated if the first part is true. These here can also cause some problems, so you got to be wary and watch out for them. Because if you're expecting this first one to evaluate, or if you're expecting a certain variable or something to happen here, but it doesn't, and then you need this to evaluate in your code, but it never will happen because the incoming value is not going to allow the second part to be evaluated. Those can be tricky to track down. So what do we have here for conditional and operator test? Well, we're going back to that kind of in stock thing there. So we have in stock is equal to false. Our price is $18.95, and we have our Boolean variable buy. So we have buy equals in stock, and you can still say it as and price is less than $20. Well, we know our price is less than $20, but since it's not in stock, even though it's an and, we still do not buy it. So the only way to get that other part there to evaluate, and now what we'll do here, if we'll do price, we'll set our price equal to, where's my insert on? We'll set our price equal to $28.95. So now the second part gets evaluated since the first part is true, but since before the first part was false, the rest of the expression just kind of went to the wayside and it didn't even worry about it. So be careful with these. They can be tricky to track down bugs if you're expecting something to happen and it doesn't because an incoming variable or something is something that it shouldn't be. Alright, next one is the conditional OR operator. This is the double pipe. It's very similar to the Boolean OR operator in that it evaluates two expressions and returns true when either expression is true. The difference is when the first expression evaluates to true, since either expression can be true, it automatically assumes the overall expression is going to be true. Therefore, the conditional OR operator returns true without evaluating the second expression. The second expression is only evaluated when the first expression is false. Very similar to the AND operator. So we'll use our mileage and change oil thing again here. So how we have it set up here is our mileage greater than 5,000? We have it set to be that, yes. Are our months greater than 3? Well, our mileage is set to greater than 5,000. Or is our months greater than 3? So we know this one returns true, so this one didn't even get checked. And we can go ahead and demonstrate that again. We can set our months equal to 4. And it still comes back true because this one is greater than 5,000. That really doesn't show up too well, does it? Let's do this here. Let's check if our months, like if our months are less than 3. We can do that. So months are less than 3, true. So let's put this back to 4, true. So if we turn just to 4,500, that's okay. Shift F5 out of that. Alright, where'd my mouse go? We'll change this to 4,500. Alright, so now what we got here is mileage is greater than 5,000. Absolutely is not. So it goes on to the second one. Here are your months less than 3. Absolutely not. So we don't need to change our oil. See, these can be difficult to manipulate and work with too. So if we do it like this, that represent a little bit better there. So mileage, since it returned false, it goes ahead and evaluates the second statement here. A little easier for you to see now. Now like everything's straightened back out. So our months are greater than 3, so do we need to change oil? Absolutely. So that's the conditional OR operator. Again, very similar to the conditional AND operator. And again, watch out for these statements not getting executed if they need to be. So let's go back to the PowerPoint here. And here's what I'm talking about, side effects. You must watch out for the side effects that can occur with conditional Boolean operations. If your program depends on the expression on the right to be evaluated and it's not because of the condition, this can lead, like I said, to hard to find bugs in your code. This is also called short circuit operators. So again, watch out for those and hopefully they don't cause you too many problems. Alright, assignment operators. We've already demonstrated plenty of examples throughout our lesson here so far of simple operators in action. This section shows compound operators and what you can expect from them. Compound operators are just kind of like a shortcut in how to do stuff. So like when you do like a plus equals, like total plus equals 3. Multiplication, this is how they all work basically right here. So we have our int total equal to 7, then we do total plus equals 3. Basically what it's saying is total equals total plus 3. Take my total, add 3 to it, set it back equal to itself. That's how these all work here. So it's just kind of a shortcut so you don't have to write it out longhand. So you can go ahead and certainly copy those down or find them. I like using the shortcuts when I can. It just reduces the amount of space it uses on your editor there and whatnot. So when I can, I use the shortcuts. If not, I'll write it out the longhand version, maybe for readability, if something, whatever may be going on, or how maybe whatever mood I'm in that day. Who knows? It doesn't matter which way you do it. They all do the same thing, but some people want to condense their code down as tightly as possible and make it the most difficult way to read. I, for one, am not like that. So other than that, that's going to wrap up this video here today. This is going to be part B of our expressions. We still have ternary, and then one more video after that. So 2 more videos yet in lesson number 7. So hopefully today you enjoyed the video. If you do, go ahead and give it a thumbs up. If you have any questions or comments, go ahead and certainly leave those below. If you want to see more of these, go ahead and click subscribe, and I'll have another video for you soon.